topic, I hope that I am an odd man out. I think that I must be the odd man because as our NGO, Mr. Prabir Banerjee has been discussing, so with reference to water resource, if it is our groundwater resource or if it is our surface water resource, we are highly contempt about what is, because we want excess amount of water or what is the availability today. Because I cannot plan for next 20 years or next 30 years. Because as per water is concerned, I hope you might be knowing its issue or its significance. So I want it today because I want to see what is the quantum of water that is available today, so that by knowing that I can plan for the next 20 years or 30 years. So that taught me, or that brought me to one conclusion, or that brought me, so that why can't we speak about integrated water resource management. Generally, whenever I go for speaking, I speak with reference to integrated water resource management, where I will be integrating different type of techniques, for example, like resistivity investigation or modeling or water quality assessment, and then I will be coming to one conclusion regarding what has to be done with reference to enhance the water quality as well as enhance the water quantity in that particular region. But recently I heard about a terminology, what we call it as Socio Hydrology. So which has gained significance for the past 1 decade or something like that. So Socio Hydrology here indicates, so rather than speaking, rather than having government official as well as the technical person, why can't we directly take it to the end users? For example, the people, those who are really in need of that particular water. So that aspect is what we call it as a social hydrology. So now major amount of research or major amount of research are being put forward with reference to socio hydrology. That means, for example, if I want to speak with reference to socio hydrology, I will be telling that, yeah, for example, if I am telling that the quantum of water that you are drawing here is in excess, then I cannot go and explain to the public. He will be asking, how do you know that I am exploiting such amount of water? So he will be in confusion, or he don't know exactly what is being happening there. So rather than that, why can't we go and explain him? So this is the problem that you will be facing. For example, if you go on exploiting the water, if you go on using this particular water resource, or if you go on using the excess water that is more required than for you, then what will be the problem? That has to be teach to him, or that has to be taken to him. So directly he will be knowing, yes, this is the particular problem in this particular region, so that we can directly come to a conclusion. That particular aspect is what we call it as a socio hydrology. So when coming to the next aspect, with reference to your groundwater, generally I told that when it is your groundwater, we are with reference to day-to-day activities, because I want water now. I want water for today's utility, to drink, for my regular utilities. So when it is your water, we speak with reference to 2 or 3 different type of criteria, where I will be, as an hydrogeologist, I will be telling that there are 2 different type of an issue, what we have to give more significance. So issue number 1 is with reference to recharge. For example, whatever may be the type of your terrain, whether it is your hard rock or whether it is your coastal type of an environment, we have to give more significance to recharge. Because Pondicherry being a coastal environment, we give more significance to the quantum of water that is available. Here, I hope that we have generally sedimentary type of an aquifers. So we give more preference to one particular type of an issue, what we call it as your saline water intrusion. So we speak that if this is the amount of water that we recover, there are greater chances of saline water intrusion, and then we plan that we go for rejuvenation of your water bodies, like rejuvenation of your tanks or rejuvenation of your pond, and then we speak with reference to what is the amount of water that can be incorporated, so that we can enhance our water utility. But we give less significance. Less significance is given where you see that whenever it is your climate change impact, we can see that your sea level rise is a primal criteria, where sea level rise is directly correlated with that of your amount of water that fall on the earth surface as your recharge, and the sea level rise is also influenced by the quantum of water that we extract from the different type of an aquifer. For example, from the shallow aquifer or from your deeper aquifer, the amount of water that we are extracting plays a significant role. Number 3 is the quantum of your seawater that enters into your aquifer, whether it is your shallow or whether it is your deeper aquifer, that plays a significant role. So all these criteria is linked with one primal issue, what we call it as your sea level rise. So when we speak with reference to greenhouse gas emission, or when we speak with reference to your temperature increase, or if you speak with reference to your changing in precipitation scenario, or if you speak with reference to change in your what we call it as your the amount of recharge. So all this will be coming where, what will be the solution for this? What will be the end user for all this? The end user will be the people, those who are residing in the coastal regions. So whatever may be the amount of glacial melt, whatever may be the amount of your temperature increase, so it comes down by your river, or it you can see that it will be accelerating your temperature, so that it enhances your temperature of the seawater. So automatically you can see that we are the people, those who are residing in the coastal region, are more prone to climatic type of a disaster, that too with reference to your groundwater type of resources. So that is one particular aspect. And so, when as told by me, whenever I told that I will be speaking more with reference to what are the different type of integrated issues for like what are the different type of techniques that can be correlated together, so that we can increase recharge, or we can reduce the quantum of water that can be pumped from a particular environment. That aspect I generally used to speak. But when I went through the different type of literatures that are available with reference to your climate change. So I found that there are 4 different type of an aspect that generally is where they speak with reference to climate change. Number 1 is what we call it as your temperature. That is what I already told. And number 2 is with reference to your rainfall. And number 3 is with reference to your sea level rise. And number 4 is with reference to your tropical cyclone. So whatever may be your climatic issues, your sea level rise or your greenhouse gas emissions, you can see that the net resultant will be the, we have, as told by me earlier, the net resultant will be where you can see that there will be a rise in the sea level rise, so which also influences your the amount of abstraction that we do from the aquifer. So this made me to further go into various literatures that are available. So whenever we speak with reference to climate change, with reference to water resources, so they generally speak with reference to your the amount of extreme rainfall, or with reference to amount of your percentage change in the stream discharge, or the quantum of water that a stream can discharge within a particular region, or the amount of precipitation that will be prevailing in a particular region. But to my surprise, I couldn't find, to my surprise and as per my knowledge is concerned, I couldn't find any paper that directly correlates your groundwater quality or your groundwater quantity issues and its correlation with that of your climate change. So there I thought that why can't we, so for example, if you see, whenever we speak with reference to climate models, we have numerous climate models, which will be taking into consideration your satellite data, or which will be taking into consideration your sea level variations. They will be having their own data sets, which require some various inputs, and it has its own disadvantages, and it has its own criteria. So if that particular type of an input is required for a model, where they will be coming with a conclusion that, yeah, this will be the amount of sea level rise if this is the rise in the temperature. So, and that too you can see that it has been planned for the large study areas. For example, if it is regional type of studies, yes, climate model exactly works. So at this instance, I saw that our group saw that why can't we build a climate model? For example, by considering local scale, for example, why can I go for 200 square kilometer area or 200 kilometer coastal stretch? Why can't we have your own model without considering the data sets that are available, or without considering the various different type of models that are available? By having our own model, the simplest model, what we use in the field of hydrogeology, why can't we develop that particular type of a model? And that was my intention, and that is the main perspective of my today's presentation. So now I will be concentrating more on sea level rise. As told by me, whatever may be the type of issue, greenhouse gas, temperature rise, so the net resultant will be, who will be the influensive or more influensive, it will be the sea level rise. So when it is your sea level rise, we speak with reference to population. Number 1, population. We'll be speaking with reference to population, like there is increase in the population. Then automatically we will be speaking with reference to 2 different type of criteria. For example, what is the quantum of your inundation? So let me stress you, when it is your sea level rise, you can see that vast number of models are available with reference to inundation, with reference to vulnerability assessment. For example, by considering this is the scenario, This is the elevation, or this is your what is that? Your change in the land use, or change in the land use type of an criteria. If this is the criteria, what will be the quantum of your vulnerability due to the sea level rise has been taken into consideration. But as to my standard, you can say, as to my knowledge, you can see that sea level rise has never been correlated with the quantum of water that is being pumped from your shallow aquifers as well as your deeper aquifers. That is the main perspective of my study today. So generally I told them, so when it is your quantum of your water but that is being pumping or that has been pumped, we speak with reference to today's availability. What will be the quantum of water that we are pumping today? Then we don't speak with reference to climate change, because we have to give an justice for today's water, what we are using. Or if we use, this is the amount of water that we are using today, what will be the perspective after 10 years or 20 years or 30 years? That we generally don't take into consideration. So now I have to couple, or now I try to couple climate aspect with that of a simple model, hydrological model, or a hydrogeochemical model, or I will not call it as a geochemical model, or I can simply call it as a flow model, groundwater model, which gives us information regarding the flow of water in a particular region, and the velocity of water that is flowing in a particular region has been correlated with that of your sea level rise. So my intention is, if there is chances of sea level rise, it has been already predicted that 0.3 millimeter will be the quantum of sea level rise per year. So my intention or my finding is that, our finding based upon our lab report, our finding is that if we increase the quantum of recharge, if we reduce the amount of water that we are pumping from the coastal aquifers, your shallow aquifers or your deeper aquifers, definitely there are chances where we can pull or we can push the sea level rise to an extent of about 0.3 millimeter, by taking into consideration where we have to give significance to two different type of criteria. Number one, recharge. Number two, your abstraction, the amount of water that you are pumping from an aquifer. These two scenarios has to be taken into consideration. So generally you can see that this is the prediction. We have lot number of predictions with reference to models. What models? With reference to your temperature change, with reference to your sea level rise. We have numerous type of a model which predicts that in the year 2025, the rise in the sea level will be 0.5 feet. And in the year 2050, the rise in the sea level will be 1.5. So that there are lot number of predictions. So now what we did, by considering the recent phenomena, by considering the recent sea level, where we took the difference between your mean sea level and your high tide region and the low tide region, we considered that as a mean sea level, and we varied the pumping scenario, the quantum of water that are being extracted from the coastal stretches or from the shallow aquifer. We varied that. And we found that by reducing the pumping and by increasing the recharge, there are chances where we can push or we can easily reduce the impact due to your sea level rise. That was the intention behind that. So when it is your sea level rise, I told that because we are the end users, we belong to the coastal stretches. So whatever may be the impact, it will be directly felt that where you can see that sea level will be rising. So when it is your sea level rise, we speak with reference to two different type of criteria. Number one, we have tide gauges. And that too, you can see that the data set is more regional in nature. We have tide gauges in Chennai, we have tide gauges in Andhra, so that you can see that the total stretch will be greater than 1,000 kilometers, and its prediction doesn't give us any significant outcomes. So, and the another important criteria is your satellite altimetry. These two different type of measurements are generally used to predict your sea level changes. But rather than that, you can see that. So now coming to the model sea level prediction. So when it is your prediction, you can see that as told by me, it comes around per year, it will be around 0.7 or 0.3 millimeter, and you can see that it has been concluded that the sea level rise is not being influenced by your major parameters like that of your greenhouse gases. It is mainly influenced by parameters like that of your gravity, the altimetry present in that particular region, and the nature of your land use and land characterization influences the quantum of your sea level rise. Right. So this is the prediction. So when we saw that what are the various studies that are available with reference to direct impact of your sea level rise on the coastal aquifer, as told by me, there were large number of studies which predicts your sea level vulnerability due to your sea level rise. Or how much will be the lead, how much amount will be the rate of your inundation. So which areas are more vulnerable? What will be the extent of your sea level? What will be the extent of your sea level rise? So that type of data has been available, but no correlation has been found with reference to the groundwater pumping, its recharge, and your sea level rise. So that was the main intention. So now coming to our business, I told that I will be using a simple model. It is your groundwater flow modeling. It is a software which takes into consideration 3 different type of criteria. It is not an software that requires more expertise. It is a simple software which can be utilized by all the people, which require some basic data sets, so that by giving that particular input data sets, we can predict changes in the groundwater direction. You can predict change in your water level, and you can also model if this is the amount of pumping, what will be the range of your velocity or your groundwater flow can be predicted. So it works with the principle of, you can see that the model is visual mod flow. We call it as a visual mod flow. It is an easily available software. Little expertise is required, so that by using that particular expertise, you can easily work with reference to that model. And it works on the concept of 3 different type of criteria. What is that? With reference to groundwater flow direction, number 1, if this is the quantum of your pumping, how much will be the variation in the water level? Question number 1. That will be answered. Number 2, if this is the variation in the pumping, what will be the change in the velocity of your groundwater? These 2 criteria can be easily explained when you go for your groundwater type of modeling studies. So now I told that all the models with reference to climate change scenario, or with reference to hydrology, or with reference to groundwater, predict for larger scales, regional scales. But so our intention, why can't we go for a prediction for a local scale? Why can't we take 200-kilometer coastal stretch and we predict the your water level variation, and why can't we compare with that of the sea level rise and see what factor is influencing, whether it is the sea level rise influencing your groundwater quality, or is the sea level rise influencing your groundwater quantity. That aspect, we have to get the answer of that particular aspect. This was the coastal stretch that we have already modeled. We took for our modeling studies. So here you can see that Pondicherry was not taken into consideration because that didn't come inside our particular study area. But you can see that Karaikal was being taken into consideration. So this aspect, because we are already working for one particular aspect, one national mission with reference to submarine groundwater discharge, for which this is the particular study area we have considered, and it has been taken for modeling studies. So now, you can see that, first of all, as an hydrogeology, we should see which type of aquifers, or what are the different type of aquifers that plays a significant role. So with reference to the 200-kilometer coastal stretch, it has been classified into 5 different type of an aquifer. Generally, we will be speaking with reference to shallow aquifer. For example, if it is your Pondicherry region, your alluvium aquifer will be the base. And below that, you will be having your Kadalur sandstone, your tertiary aquifer. So first of all, in the modeling protocol, it is very much essential to discriminate the aquifer types. What is the shallow aquifer? What is the deeper aquifer? And what are the elevations? How far your aquifer varies with reference to your dimension has to be taken into consideration, right? Then after that, your elevation has to be, as told by me, your elevation has to be taken into consideration, because all generally groundwater or your surface water, it flows from higher elevation to lower elevation. So we should take into consideration your elevation phenomena. And number 2 is with reference to your recharge. I have been continuously stressing that recharge plays a significant role. What type of recharge? It may be your rainwater harvesting, recharge through your rainwater harvesting, or recharge through your natural processes, what we call it as the rainwater that directly falls on the soil surface, and the process of infiltration is what we treat it as a recharge. So recharge varies from location to location. For example, if it is your forest, the quantum of your recharge will be higher. If it is your building area, and if you increase the amount of your rainwater harvesting, the quantum of your recharge in that particular region will be influencing. The primary concept of the model is, what is the quantum of your recharge influences your water level. Recharge is equal to discharge, where you will be getting variation with reference to water level. So that is what we call it as your hydrological budgeting. So we want to know the input. What is the input? Recharge is only the, precipitation is only the input. What are the output? We extract water for different utilities. Then evapotranspiration is taking place. So what is the quantum of water that has entered inside an environment minus the quantum of water that has been extracted? So change in the storage, whether it is negative. If negative indicates, then we have consumed excess amount of water. If it is positive, then your recharge is not equivalent to your discharge. This is what we call it as a water balance equation, and we try to give a solution for this water balance equation, and it has been correlated with that of your climate change. So when it is your model, boundary condition plays a significant role. What is a boundary condition? We have to restrict our model domain. I cannot tell that, no, all the waters are flowing directly to the sea as discharge. No, I cannot tell like that. I should come for some modeling, some boundary conditions. This is the restriction. No, this is what I have to conclude. This is my study area. So for that, we generally go for lake boundary condition. What is lake boundary condition? If you have lake or if you have pond, the quantum of recharge directly to the pond can be entered into the model. It is with reference to your recharge. If it is your river, then you can enter the quantum of your recharge by the process of your river. It can be entered into the model. And if it is your, for example, constant head, you can see that all along the coastal region, I have given a constant head boundary. What is constant head boundary? That is the location where your seawater and my fresh water interacts, where there is variation in the density. Seawater will be with greater density, whereas my fresh water will be with lower density. So its interaction is not only confined to the surface, where we speak with reference to sea level rise, it is also common below the ground surface, what we call it as an aquifer. Due to the sea level rise, not only surface vulnerability, not only with reference to your surface vulnerability, it is also more common to your aquifer vulnerability. Sea level rise also influences your aquifer, which is also in correlation with that of your pumping. The scenario will be very drastic, or the scenario will be very, what to tell that it will be, that is what we have to take into consideration. So that is, and then this is the aquifer characterization that have been attempted. So I told you that because this is our project area where we have worked with reference to signify the quantum of recharge and the sea level rise. So Pondicherry is above that, above Kadalur. But you can see that we took into consideration your Karaikal, which comes into your boundary. And there are aquifer parameters. Because I hope this is not right place to speak about hydrogeological scenario or something like that. But my intention is to tell that don't go for regional models. We have our own models. You develop your own model. Don't predict, for example, if they are predicting 0.3 meter increase in your sea level per year. So we are forced to depend upon that particular model. For that, then we thought that why can't we have our own model to see what will be the impact of sea level rise, or what will be the impact of your pumping, because we are highly confined to that of coastal environment. That was the intention, and that was the main criteria of this particular theme. So now, water level. I told you, no, because water level here indicates the water level that is maintained in the aquifer, which plays a significant role. We have three different types of aquifers along the coastal stretches. We have shallow aquifer, we have intermediate aquifer, we have deeper aquifer. So majority of the Pondicherry people, they are getting water from the deeper aquifers. We call it as a Cretaceous aquifer. Or we are at the phase of exploiting tertiary aquifers also, where shallow aquifer has been completely used. There is no water. I will not tell that there is no water. It has been completely utilized. We are planning to utilize deeper aquifers, your Cretaceous and your tertiary aquifers, where we lack proper management practices. What should be the quantum of water that should be extracted from your tertiary aquifer or your Cretaceous aquifer? So tertiary and Cretaceous here indicates deeper aquifer. Those aquifers potentially contain water present at a depth greater than 600 meters. So all the pumps that extract water, are confined to this deeper aquifers. Okay. So that we call it as an water level. What is the significance of your water level? Water level will tell us what is the amount of water. We call it as a piezometric head. It gives us information regarding what is the amount of water present in the well. If it is down below, then it signifies that the water condition at that particular, at that location, at that piezometry is lower. Then another important scenario is your pumping wells. As told, we are giving more significance to pumping. Pumping here indicates pumping for domestic utility, pumping for agricultural utility. We have standard values. It has been already calculated. Considering 160 per liter, 160 day or 160 liter per day, and considering the agricultural practices, considering your land use, land change, water pumping has been assigned, so that you can see that the pumping wells have been assigned for the entire stretch of the study area. Around 120 wells have been assigned, considering that much amount of wells are pumping this much amount of water. Let it be 1200 liters per second, or let it be around 1400 liters per second. That is the amount of pumping available, or that is the amount of pumping that is going on in that particular region. So we have very good data set with reference to CGWB. With your groundwater authority, we have very good data set with reference to pumping. So that pumping has been assigned for all the wells that tap shallow, intermediate and deeper aquifers. So now you can see that we are giving two criteria. Number one, water level, variation in the water level, and number two, with reference to pumping, what is the amount of water that we pump. And this has been considered for 10-year period. We generally, for model, we at least require 10-year data set, monthly data set, January, February, March, 12 months per year. We will be considering pumping, we will be considering the variation in the water level, and it has been considered for 10 years. From 2010 to 2019, we have attempted for, or the modeling has been considered. Because we have to validate. We cannot simply model and come to a conclusion that this is the output that has been generated from the model. Right. So now this mod flow, a simple software which requires some data input like aquifer parameters, or the depth of your aquifer, the quantum of water level variation, and the amount of water that can be pumped from an aquifer. You can see that it has to be this particular model. I told it has to be run for 10 years period, and we call it as a transient and steady state with reference to variation in the stress period. What is stress period here? Stress period here is, we will be taking 3 stress period per year, where January, because due to the adequate rainfall during your northeast monsoon, the quantum of your pumping will be reduced. But when it is your summer season, during the month of March, April and May, the quantum, because due to the lack of your rainfall, because we Pondicherrians are the coastal stretch of our southern Tamil Nadu, 95% depend upon groundwater resources, even though surface water resources are available, because it has been mainly intruded by your tidal inundations. And they are more seasonal in nature. During your precipitation or during your rainy event, we will be having water flow in this on the surface flows, or in the rivers, or as rivers. Rather than that, we have to depend more on groundwater resources. 95% of all the utility, irrespective of the coastal regions or coastal Tamil Nadu, depend upon groundwater resources. By considering that, we have to validate our model. As told by me, we have to run the model, we have to predict, and we have to validate our model. What is validation here? Validation is like patting. Yes, what you have done is good with reference to a particular scenario. It has to be validated. So we can see that we have validated the model, and we have given around 19 to 20 water level variation wells, or wells have been given, and the water level variation has been recorded for 10 years duration, and the pumping has been assumed for 120 wells. And the variation in the pumping has been recorded for 10 years, and the stress period was 1 month, for considered for 12 months duration, or 12 months duration. 12 in the sense, we can run the model for 1 year, you can run the model for 5 years, you can also run the model for 24 years, whatever may be the criteria. So I will not enter deeper into the model. My intention is to show the output with reference to your model. So here, Water level variation has been recorded with reference to all the three different type of aquifers, shallow, intermediate and deep. So it has been considered for three different stress period as told by me, because during summer the pumping will be higher, and during your monsoon the pumping will be lower, where we have excess rainfall which has to be taken into consideration. And number 3, post monsoon your pumping ratio will be higher, your pumping ratio will be lower, which has to be taken into consideration, and this is with reference to your water level variations. So we have model, you can see that here water level is found to be influenced with reference to elevation, and number 2 with reference to drafting, what I call it as abstraction. Where and all we have greater drafting, there the depth of the water level was higher. Where and all the drafting was found to be lower, then there your water level was found to be more shallower in nature. So you can see the scenario there. Red indicates deeper water level, and your blue indicates shallow water level. This has been iterated, this has been continuously run for 10 years period, and I am giving the data with reference to one particular stress period. Right. So now you can see that diagram there, where pumping wells are, you can see the pumping wells, and you can see some vectors, what we call it as your vectors, are line diagrams, which indicates the direction along which your water is moving. So here, with reference to pumping, if you draft more amount of water, you can see that my arrows will be towards the pump, which indicates greater amount of groundwater extraction. And based upon the color, we can easily designate the variation in the vector. For example, when my vector color is red in nature, it indicates excess pumping. I am removing excess water. When it is blue, it indicates though the flow is confined to one particular direction, the quantum of velocity is lower, which indicates significant pumping is not influencing that particular velocity vector in a particular region. There are 3 colors we generally use. Color number 1, we call it as red, which indicates excessive velocity. Blue, which indicates low velocity, and green, which indicates intermediate velocity. So based upon that, you can classify the water, whether the water is moving from the coastal region to your aquifer, or your water is moving from your aquifer to the coast. You can easily designate. That is what we have done. And when coming to your balance, I told that your inflow and your outflow is what with the reference to your storage. So I told you that when it is your sea level rise, or when there is mismatch between your the amount of water present in the aquifer and the amount of water that you are abstracting, then definitely there will be deficit. The quantum of your water that is present in the aquifer will be deficit, and that is what we call it as a zone budget. Here you can see that I have given 4 stress period: 2018 September, 2019 January, then 2019 May, and 2019 September. You can see that all the stresses are negative in nature, -2, -3, -4 or something like that, which indicate my input is lower, where output is higher. What is output here? Output is where I extract water from the aquifer. So if your input is equal to output, then there won't be change in the water level. That particular scenario has been considered. And here you can see the flux. Flux here indicates groundwater movement, velocity of your water, what direction. So where and all you have your red, there the velocity indicates greater speed. Greater speed here indicates we are removing excess water. Pumping is very, very high. Green indicates low. The pumping is very, very low. That scenario has been considered. And here you can see a lot of lines here, lot of which indicates velocity. We have 3 different type of color here. So there you can find along the Kadalur region, red, which indicates inward movement. Red here indicates inward movement. What is moving inside? Seawater is entering into my aquifer. What does that blue color indicates? And you can see that it is from mainland to the coast or mainland to the sea. What does it indicate? It indicates that fresh water is moving from land area to the coast. So red indicates excess pumping, where due to the excess pumping, though there is variation in the density, seawater is moving inside. In absence of pumping or lower the pumping, if you get blue color line, which indicates that fresh discharge is taking place. Based upon that model, we have demarcated the locations along the coastal stretch where intrusion is taking place and where your fresh discharge is taking place. That has been attempted. Right, now coming to our business, I told you no. So it has been what we have done as of now. As of now, we have isolated locations by considering today's pumping, or by considering the pumping that we do it now for this present year. We have modeled and we concluded and we came to a conclusion with reference to where saline water intrusion is taking place, with reference to pumping scenario. Greater the pumping, greater will be the chances for seawater to intrude. After that, I want to speak, I have to correlate my scenario, my local scenario, with that of the global scenario, where I took into consideration the sea level rise, where three scenarios have been taken. One is 0.2 meter rise in the sea level, and the other is 0.6 meter rise in the sea level, and the other is 1 meter rise in the sea level with reference to various predictions. We have numerous predictions within this particular year. And so that prediction has been taken into consideration and it has been predicted. What has been predicted? If sea level rise happens for 2 meter rise in the sea level, you can see there. So we have modeled with reference. What did we do? We increased the water level there. What water level? We increased the elevation there and we increased to 0.2 meter and we increased it to 0.6 meter and we increased it to 0.1 meter. And by considering the scenario, what was the view or what was the variation with reference to water flow has been modeled. So you can see that. Now what did we do? Now present pumping scenario was not taken into consideration. What we did? We increased the pumping because it has been predicted for three scenarios. So that means 0.3, 0.6 and 1 meter. So for this three increase, what we did? We didn't consider the actual pumping, but we increased the pumping scenario correlating with the rise in your population. So we concluded or we came to a conclusion that in the year 2040, this will be the amount of rise in the population. So this population rise will consume this much amount of water. Based upon that, we increased the pumping or we increased the abstraction of your water. You can see that it has been given for 3 stress period. 20% increase. Then the other is your 30 and the other was 40% increase for a draft of about, so this was the consideration for 1 meter drafting or 1 meter interflow. And we modeled, we predicted. Prediction was with reference to 3 scenario. Once again I am stressing point number 1, pumping. We increased the pumping. Point number 2, there was no change with reference to recharge. Recharge was kept constant. We increased the pumping. So based upon the pumping, based upon the quantum of water that has been pumped, you can see I am keeping 2 different type of a model scenario, and you can see that each and every scenario represent one particular criteria. For example, what will be the inundation, what will be the intrusion, or what will be the amount of sea level rise that will influence inland has been modeled by considering pumping and recharge. This is an exact scenario with reference to groundwater, with reference to aquifers. It doesn't take into consideration vulnerability. It take into consideration the quantum of water drawn, which directly influences your aquifer water. So we generally speak with reference to seawater intrusion. Now I am coupling seawater intrusion with sea level rise. So where and all we had seawater intrusion, you can see the other image there. Red line indicates seawater. There the inundation was very much higher. It intruded up to 0.6, it intruded up to 6 kilometer. Where and all there was freshwater discharge at present taking place. There the inundation due to your sea level rise was lower. And where and all it was intermediate, there the quantum of your inundation due to your sea level rise was lower. That was the scenario predicted for 2 different, we took Kadalur as well as we took your Nagapatnam region, and the southernmost tip is where you have your Karaikal. So it has been predicted for your Karaikal by considering 1 meter rise in sea level, but by considering the next 20 years or next 40 years, what will be the quantum of your sea level inundation has been modeled. So now what has been, or what has to be, what are the other uncertainties? Now we have to speak with reference to uncertainty. If it is a model, there should be uncertainties. Uncertainty here indicates we didn't take into consideration the tidal variation. We took the present day sea level rise, or the present sea level mark has been taken into consideration. We didn't take into consideration sea level seawater intrusion, but it reflected very well in the model. Where and all we had seawater intrusion, there the level of inundation was higher. Then, and the initial lead for sea level is the present sea level. We didn't take into consideration the rise, sea level rise. We modeled with reference to the present sea level scenario, where the berm region was there. Intertidal zone has been taken as the sea level mark. By considering that, we modeled this study. And it has been modeled for two scenarios, transient and your steady state. And coming to the prediction, so because being this particular webinar or your seminar, which focuses on climate change, so what will be the solution, or what, as a modeler, as an hydrogeologist, what will be your solution? So my solution, what I want to suggest is two scenarios has to be taken into consideration. Number one, increase recharge. Number two, reduce your pumping scenario. Irrespective of your utility, reduce your pumping scenario. So if you reduce pumping, increase your recharge, irrespective of your terrain, irrespective of your recharging characterization. Characterization here I indicate whether it is pond, whether it is building, whether it is forest, whether it is your what is a tank. You try to increase the recharge. You go for deepening or cleaning of your pond. You quantify the amount of water that can be recharged. If your pond is being desilted, that can be done. You desilt your river. Then reduce your pumping. Where? Along the coastal stretches. We have calculated the present day pumping. It should be reduced. How? If you increase recharge, then automatically you can see that there will be decrease in the pumping scenario. So reduce increase your recharge, reduce your pumping, automatically we can see that the reverse will happen. Where? Your sea level rise, or what we call it as your seawater intrusion, or your sea level rise, we can see that by this phenomena we can push it back with reference to the density variation. So that is the message that I want to deliver in this particular scenario. You can see that there are a lot number of methods. We call it as a managed aquifer recharge. How to enhance the recharge? What are the techniques that are available so that the recharge can be enhanced with reference to different structures like borehole recharge, or your pond recharge, building recharge? You can quantify, or forest recharge. You quantify, you try to significantly increase the recharge so that definitely there will be reduction in the pumping. If reduction in the pumping happens, then definitely, irrespective of two scenario, man-made, number one, sea level, your seawater intrusion, number two, nature, or this is also induced by human. Even though we call it as natural, it is being induced by your human. We can restrict, or we can further predict migration of your seawater along with that of your saline water intrusion. So thank you for your kind patience.
Thank you so much, sir, for sharing with us your very intensive studies on coastal climate resilience building.